Hi, I'm Kavya Kompella and I'm a master's student in the Department of Computer Science at Kansas State University. Predictive analytics and data-driven approach to algae bloom prediction is my research topic and also the topic for the presentation. Toxic foaming cyanobacteria species in the freshwater reservoirs contaminates the water and makes the water unusable for household purposes and also agriculture purposes. So, additional research is needed to understand and also predict the blooms in these freshwater reservoirs so that we can take some uh, action to control the growth. So, the research objectives for this project is to develop a machine learning based and also a data driven machine learning model using the high frequency monitoring data and predict algae blooms before the growth escalates in the whole freshwater reservoir, and also identify the factors or the features which are influencing these prediction and to control the growth. The data is collected from two resources for this project. The in-lake water quality is collected from a multi-parameter zone, which has features like cyanobacteria, phycocyanin, chlorophyll, dissolved oxygen, etc. And the environmental data like turbidity, humidity, wind direction, air temperature, etc., are collected from U.S. Army Corps of Engineers. So the machine learning models which I am using is ensemble machine learning model. This model, as the name suggests, as the name says, it's a ensemble of different learning models like random forest, decision tree, k-neighbors, Gaussian, and support vector machine. The results in the results section are and the results of the posture represents the data from these and from this ensemble model. Here we can see that although the model is not accurately capturing the peaks in the data and also extreme highs and extreme lows in the data, but overall this model is able to capture the trends in the data properly. So coming to the observations. The first graph in the observation represents the Pearson correlation between the variables in the data set and observed phycocyanin value. So this is the correlation between the variables of the data set and the phycocyanin value. The second graph 5 in the observation section represents the correlation between all the variables and the model, the ensemble machine learning model predicted phycocyanin value. And it is evident that the correlation between the variables of from the observed value are pretty similar to the values from correlation values of the model. And it is also seen that temperature, turbidity, specific conductivity, dissolved oxygen, chlorophyll, air temperature, and inflow are showing good correlation with the predictions. As a part of my future research, I will be working more on LSTM. LSTM is also known as long short-term memories model. And this is a kind of recurrent neural network which is capable of learning long-term dependencies. So I will work on this model further and make it more efficient. Once I'm done with improvising the model, my next task is to uh, ensemble this machine learning ensemble model with this LSTM to make even better predictions. Thank you.